Pressure. Pressure is force divided by area. And I have two pictures here. I have one here with you have a foot and you have stiletto heels. Stiletto heels actually can be very dangerous because if you notice that your weight is on this little point right here, and of course you have it up here in the ball of the foot, but you have your weight is primarily when you're walking, you come down on your heel. Whatever your weight is, it's all on that one small point. So it's all in a very small area. And so when it comes down on your foot, all right, it's actually a great amount of force. So basically, most of your weight is in a tiny point. Stiletto heels have been found that they can actually pierce skin. You know, you watch these different CSI shows that are on. I remember seeing one where someone actually stepped on someone and the stiletto actually pierced their abdomen. Kind of scary. You think about it. Up here you have a bed of nails. That is actually, if you want to call it a trick, a scientific trick. But what do you think? How can people lay on a bed of nails? Is it contrived? You know, what is it? Well, the idea is like if you were to step on one nail, it would pierce your foot. But when you have thousands or millions of nails, and usually what they do here, now you can't, this picture, they look like very sharpened points, but what they do sometimes is they actually shave these down so they're not points, that they're more flat. And you actually can lay on a bed of nails. I wouldn't suggest you try that. But you can actually do that because what happens is that your weight is distributed among all these different nails. So it's kind of interesting how that works. It's not fake. It's actually real. A couple things you need to know. Area. We've talked about volume before. All right. Area is length times width. Volume is going to be length times width times height. All right. Now I want you to notice something. When we had volume, we had meters cubed, feet cubed. You had three things we were multiplying together. Notice here you've got two. Length times width. They have to be in the same unit. So if you're going to be doing area, you want to make sure that you're measuring your length in meters and then your width in meters. And the same thing if you want feet, make sure they're both in feet. All right, but the clue is when you look and notice that they have that 2 there, that means it was meters times meters. Okay, give you meters squared. All right, variables. The pressure is usually capital P. Now, there's many different kinds of pressures that you'll see in this PowerPoint. But capital P is just basic pressure. Capital F is force. Capital A is area. In English, pressure is PSI. It stands for pounds per square inch. Very common unit. In SI, it's newtons per square meter. Now remember that pressure is force divided by area. So it's going to be pounds per square inch. That's where the PSI comes from. And this is newtons per square meter. All right, here is an example. A woman has stiletto heels on and she weighs 120 pounds and the heel is half an inch by half an inch. All right, how much pressure would the heel exert if all the woman's weight is on one heel? All right, now how would we do that? Your force is going to be your weight, 120 pounds, and your area is going to be 0.5 times 0.5, and then you're going to divide them. So let's take a look at that. All right, length times width, 0.25 square inches. See how that's squared? Force divided by area, so 120 pounds divided by 0.25 square inches, and you're left with 480 pounds per square inch, which is more than enough to puncture your skin or aluminum on an airplane. You are not supposed to be, not supposed to wear heels on an airplane, like stiletto heels. It would actually damage the plane. So don't wear stiletto heels on an airplane. All right, that I don't know if you heard that sound or not, but that was a sound effect that I had added here, where it was actually a car lift. And I just put that in as an example of Pascal's principle, where a change in pressure at any point in a confined fluid is transmitted undiminished throughout the fluid. An example would be a barometer, or here you have a car lift. Okay. Basically, when you have the pressure, all right, like it said, it can be distributed throughout the fluid. All right, I said before you there's different type of pressures. There's total pressure. First thing you have to understand is that we live in an ocean of air, and we're at the bottom of that ocean of air, and that is what you call your atmospheric pressure. Now, there's many ways that you can actually measure pressure. All right, and the two that we're going to look at are, you can say 30 inches of mercury. If you watch the weather and they talk about the barometer, you know, what they're talking about is this 30 inches of mercury, the pressure changes in our air. Or you can do PSI, which would be 14.7 PSI. So basically what you do is that's going to be your atmospheric pressure, and which one you use is going to be determined by how you have measured your gauge pressure, or what kind of atmospheric pressure, what units do you want. Gauge pressure is like, let's say you take a tire gauge and you check the pressure in that tire. All right, and you do it in, let's say, PSI. You add that to 14.7 PSI and you get total pressure. Okay, so on a tire, it not only has that pressure in the tire, but it also has pressure on it. Okay, so you just add those up and you get total pressure. Total pressure, capital P, all right, TOT for total, measured in PSI, or it can be measured in inches. Gauge pressure is PG, gauge pressure, gauge, and that's pressure. Again, PSI and measured in inches in the English. And notice, by the way, they're both English. We don't have English and metric here. Atmospheric pressure, PATM. ATM stands for atmospheric. All right, and notice that you have specific numbers in here. 14.7 PSI for the one type of English, 34 inches for another. The thing with pressure is, when I say that there's a lot of different units, there are a lot of different units. You might have heard of torr or pascals. They're also units of pressure that if in your earth science classes you probably have talked about. A car tire needs a gauge pressure of 30 psi. So that's what your tire needs to read. What would be the total pressure on the tire? Okay, so if we know it's 30 psi, so that means we have to use 14.7 psi for the atmospheric pressure. And we know that total pressure, you have to add gauge pressure and atmospheric pressure to get total pressure. Alright, so that's what we're going to do here. So we've got our equation, gauge pressure plus atmospheric. We know atmospheric is 14.7 psi. So to get your total pressure, you're going to add those two together, and when you do, you get 44.7 psi. So that's the total pressure that's on that tire. Fluid height. This is primarily used when you're talking about like water tanks. All right, is the most common. For example, if you take the water weight density, we learned that a couple PowerPoints ago, times its height, all right, and the height needs to be measured in feet. You multiply those together, you can figure out what the pressure should be at the bottom of that tank. Now, where this is also used, there are a lot of areas that have tanks that have different type of liquids in them. Like a lot of places, distribution centers for oil or gas. Right, on the premises, you might have a tank of gas, you might have a tank of kerosene, you may have a tank of some other type of liquid. Okay, basically what you do, it works the same way, but instead of water weight density, it would be the weight density of that specific substance times its height. So the equation works for a lot of substances. But water is so prevalent these days. Well, it has always been. It's an easy way to check what its pressure should be for like a water tower. Okay, we have, again, pressure is P. This time notice that we have pounds per square foot and kilograms per square meter. Water weight density. Okay, it's PW. Notice it's a funny looking P. Alright, that's actually the Greek letter rho. That's so you can differentiate it that it's not a regular pressure. And W stands for water weight. Or you can just say weight density if you're going to use it for something else. But right here, this is actually for water. 62.4 pounds per cubic foot if you're talking English. 1,000 kilograms per cubic meter if you're talking SI. Your height in your fluid, you want to measure it in feet if you're using the 62.4 pounds per cubic feet. You want to measure it in meters if you're dealing with the 1,000 kilograms per cubic meter. Okay, here's a couple of things. If you were measuring, like comparing water tanks, all right, the tank that has the greatest height has the greatest pressure. If they have the same height but different diameter, they have the same pressure. If the tank funnels down to a bottom surface, the pressure remains the same for the same depth of fluid. In other words, what you have to look at is the length of the column of water. Okay, so they can be different shapes, but it's that part in which you are getting from top to bottom. All right, that's what you'd have to measure. Okay, let's take a look at the picture. All right, here's a tank, and here's a tank. They're the same height. Which one has the greater pressure? Is it this one? All right, it's rounder, so it has a greater volume. Or is it this one? All right. Diameter or volume does not change how much pressure you have at the bottom. What matters is how tall or how much that column of water is. So it's this here. Same thing with this. It is the height. So they're actually going to be the same. All right. That holds more water. Same pressure though at the bottom because the column is the same. All right. How about this one? All right. This one is going to have the greatest pressure of all down at the bottom because it's taller than these two. Okay. Okay. Take a look at this one. If this one were at the same height as this here, all right, and these pieces here, they're actually contain the water, all right, then what would happen is that the pressure at the bottom of the tank here would be the same as the pressure in these two over here. All right, let's do a problem here. A water tower is 300 feet high. What should the water pressure gauge read at the bottom of the tower? Well, if it's 300 feet high, you're going to use your water weight density of 62.4 pounds per cubic meter. You're going to multiply those together, and what happens, feet cancel out here. One of these numbers here, see how you have 3? One of them is going to cancel out, so you're going to be left with 2. All right, so you're going to have 62.4 times 300 is going to give you 18,720, and the unit you're going to have is going to be pounds per square foot. Well, that ends the